everyone, welcome to this part of the video where we are going to have a quick introduction of the symbols that we are going to use in algebra. So for example, when we see 2x plus 3, there are certain things that you need to take note of. So let me zoom in. 2, which is the number in front of a letter which we call a variable. This is actually called, there's a name for it, it's called coefficient. The letter, we used these letters to represent numbers, and we have a special name for it. It is called a variable, okay, which means that it basically can represent any number. And if there is a number without any letters, in this case 3, positive 3 to be more precise, this is what we call the constant term, the constant, because there's only one value fixed to it, 3. So these are the 3 things that you need to take note of that makes an algebraic expression. Okay, another thing to take note of would then be that the signs plus, minus, times, divide, equal is the same meaning as in algebra as in arithmetic that you all have learnt before, and also the order of operations, the Bodmer's rule, still applies in algebra. The next part would then be to have a quick look at what we call like terms and unlike terms. Okay? So for like terms, right? Like terms will be terms that have the same variable with the same power. Okay, example of like terms would then be, you see, x, 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 x square, x square, x square, xy, 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 x square y, x square y, x square y. Constants are all like terms because they represent this group called constant terms. Okay? So you can see that when we are looking at whether is it a like term or an unlike term, we only focuses on the variable. The coefficient, which is the number or the value in front of the variable, we are not too bothered about it. As for the unlike terms, I'm going to use a gray color. Then basically it's the opposite, meaning x and y are unlike terms, x and x square unlike terms because the power is different. Same goes for x and x square and xy also different, xy, xz, yz, x square y, xy square, constant and a variable, they are all unlike terms. And the last part though for us to take note of would then be that how do we perform operations on like terms? We don't perform operations on unlike terms. For like terms, we add or subtract like terms by adding or subtracting the coefficient that will determine how many of the variables of the like terms are left. Alright, so this is a quick recap of what we have learned previously before we move on to other parts of this video or this chapter per se. everyone, welcome to this video on algebraic vocabulary, which will be useful when we solve questions in algebra. So the first point is that we do need to take note of the difference between an expression. Another word for expression is polynomial, where you notice that there is no equal sign, which means that the relationship is actually incomplete. You could see this as a mathematical phrase, and when we compare this to an equation, then you can see that there is a subtle difference. For an equation, there is an equal sign, meaning that there is a complete relationship. And in this case here, we could then see this as like a mathematical sentence. Okay? So there is a difference because the way we go about solving things in algebra matters, whether it is an expression or equation. Okay? So as we move on, we will then look at the next part, which will be what we call terms. And for terms, there is both positive. I'm going to use green color. Positive term. Oops. And negative terms. Okay? And how do we know it is a positive or negative? So for positive term, sometimes, most of the time, we do see a positive or a plus sign. And if we do not see it, most likely it is the very first term in an expression or equation. So you see in this case here, for expression 6a, there is no sign in front of it. This is a positive 6a, positive 6a. Positive 3x squared, positive xy, and so it will be positive so in this case here, positive 3 x square and positive xy. So there are two positive terms, one negative term. So I'm going to just highlight the negative 5a at the top, and in this case it's a negative 7. So negative 7. So for this particular question, expression, there is actually 3 terms here. For an equation, we also do see 3 terms. Yeah? And what are the 3 terms? First, we see let's look at the positive. 9p squared is positive, 3 is positive, 2p is negative, and so from here we can then see that there is a positive 9p squared, there is a positive 3, and there is a negative 2p. Okay? The next thing to take note of is, in any algebraic question, this is what we call a variable. So for variables are all the letters. Okay? So please remember that for all the variables, we see them as letters. Okay? They are what we call variables because they can represent any value. Okay, that's the reason why they are called variables, because they can represent any values. Okay, coefficient. Now, what is a coefficient? Coefficient is actually the numeral, the number in front of the variable. Okay, so it is what we call the coefficient. It is the number in front of the variable. So in this particular example here, we can then see 4 as the coefficient of x, positive 4 to be more specific. If there is no numeral in front, do take note there is an invisible. Let me make it bigger. There's an invisible 1 down there, okay? Because it is positive 1 xy. So this number 1 is the coefficient of xy. And of course, there's a negative half. Oops, negative half. Negative half is the coefficient of y. Okay, the absence of a numeral simply means, in this case, this example is either a positive 1 in this case or negative 1. It depends on the sign on in front of that variable. And the last thing to take note of in this vocabulary would be constant. So for a constant, yeah, let me just use a bright orange. So for constant, it is simply the number that do not have a variable, meaning it is a number by itself. Okay, so this negative 8 is therefore the constant, or what we call the constant term. They mean the same thing. Why is it called a constant term? Why is it a constant? Because the value, because the value is fixed, is constant. It is always negative 8. We cannot change the value. Whereas for a letter, which is a variable, we can replace it with any value. Alright? And with that, we have come to the end of this particular part on algebraic vocabulary. So, if you like this video at any point in time, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this part of the video where we are going to explore factorization by grouping terms. Now, what is factorization? It is a process whereby an expression is expressed as a product of its simplest factors. So if it is purely numeric factorization, example, in this case we have 12, then the 12 can be written as 2 times 2 times 3. These are all factors And in this case, we can tap on our knowledge of prime factors to help us. And so for 12, the factorization would then be 2 to the power of 2, because there is 2 of them, multiplied by 3. And in some cases, or in most cases, we don't have to write the multiplication. Instead, we could simply rewrite it as in bracket form. As for 2a plus 2b, do see that there is a common factor of, yes, 2. So what we do is that we will take out 2 as the common factor, and we are left with a plus b. Okay? And so you can then see very clearly that the a plus b will be inside here. That is the factor a plus b as a whole, because it is within a bracket. So using that same idea, I can then see that x is the common factor here, and I'm going to write x out. X. And I'm left with p minus q. Where is the p minus q? It's here. So all these are factorization. Okay? So as you can see, it is important to take note that the factorized form is the simplest form that we could obtain out of an algebraic expression. Okay? So as algebraic answers should always be left in their simplest form, where possible, where applicable, we should always strive to leave all our answers in factorized form. So that is something for us to take note. And there are many ways that we could factorize in algebraic expression. We have previously learned how to factorize by taking out common terms, common factors, multiplication frame or cross chart, and by special product. Today will be more of grouping. And for grouping, we follow the following 3 steps. This step 1, 2, and 3. Okay? Step 1, we rearrange and divide the terms into groups such that there is a common factor. And because there is a common factor, the next logical step would then be to extract the common factor from each group, after which we check to see if that expression can be further simplified by taking out more common factors. Okay? And we will, next part of the video will then be to share with you more examples of these 3 steps. Alright? So stay tuned for more. Now, factorization by grouping has 3 levels of difficulties, and in some cases, we may need to change sign. What do I mean by that? So for this part of the video, we shall explore the 2 possible ways where we can play around or manipulate equivalent terms. The first one would be this: negative x, negative y is in fact equals to negative x. Okay. Plus y. Huh? Why is that so? So for this particular first thing, I need to prove to you that they are in fact the same. I'm going to start off with negative x plus y. This is equals to negative multiplied by positive. I will get a negative x, so I'm going to expand and simplify this expression. Negative 1 multiplied by positive y, negative y. And I can see that negative x, negative y, and negative bracket x plus y, they are equal to each other. That means they are equivalent terms. Okay, so these two are equivalent to each other. So they are equivalent expressions, which means we could use them interchangeably. Okay? Now, for the other expression that we see here, negative x plus y and negative, what could this be? I'm going to share with you that it is negative x minus y. Oh, strange, right? So negative x minus y bracket, I'm going to equal to, doing the same, I'm going to expand and simplify. Negative 1 multiplied by positive 1x, negative 1x. Negative 1 multiplied by negative y, negative times negative will become positive. Yes? And sometimes we also rewrite this as y minus x, because we just rearrange the positive y in front, the negative x behind. Okay? And so you should be able to see that these terms are equivalent terms as well. So again, these three are equivalent terms or equivalent expression. And therefore, we could use them interchangeably. The only thing to take note is that I'm going to write in red color. For the third point, although x plus y equals to y plus x, x minus y will then be equals to y minus x. Because if I expand and simplify the bracket as what I did for the first 2 points, you can then see that when I'm going to expand and simplify, negative times positive will give me my negative y, and negative multiplied by negative x will give me my positive x. So these are some of the things that we could apply to when we solve for factorization by grouping. Okay? And the next thing to take note of is also that sometimes we may have to rearrange the terms to make it easier for us to be able to group them and extract out the common factors from each group. Okay? So with that, we have come to the end of this part of the video, and let's move on to look at some of the examples with respect to this particular topic. Hello everyone, welcome to this video, or this part of the video where we are going to factorize these few questions. All right, so without further ado, let's get started. So do take note of these examples. We are going to factorize by grouping. Okay, so for the very first part here, I'm going to break this into two groups. I'm going to see this as the first group and the second group. So for the first group, right, I saw that 2 is actually a common factor between 2 and 4. So 2, I also saw an x. That is the common factor. And I'm left with A and 2b. Not forgetting the negative 2b. Yep, because 4 divided by 2 is 2. I've taken out 2 as one of the common factor. I'm left with 2. As for the other group, the green color group, I am going to take out negative 5. And I also saw that y is a common factor. And once I extract negative 5y out, I would simply left with A. And at this point, you may feel surprised that Mr. Tan here will actually write negative 2b with B remaining. And why then does Mr. Tan write a negative when there is a positive? Because we must always remember that if there is a negative, if I taken out negative 5y out, and when I multiply them into expand, I should get back positive 10by. So negative times negative will give me back my positive. Okay? And once I have extract out the common factor of these two groups, I realize something. A minus 2b will be my common factor. And I'm left with 2x minus 5y. Let's practice on more question now on part B. Again, I'm going to look at two groups. This is the first group and this is the second group. And this become relatively easy. 7 is the common factor, P as well. And I'm left with 2x plus y. Yeah? Because 14 divided by 7 is 2. Next, I would take out positive 2q. This is the common factor of the next green color group. So with 4, I've taken out 2. I'm left with 2. I still have my x and my positive y. And therefore, final answer, I saw that 2x plus y is now the common factor that I am going to extract out. And I'm left with 7p and positive 2q. And let's move on to part C. And here, in this case, I would have my 2c minus 6 as one group, negative c plus 3y as my second group. 6 can divide by 2. 2 is the highest common factor among the two. I'm left with c minus 3. I'm going to take out negative y out. And I'm left with c. You might wonder why Mr. Tan write negative 3. But we must always remember that if I expand out, meaning this is negative y multiplying my negative 3, it does give me back my positive 3y. Okay? So that is the reason why I write c minus 3. And from here, c minus 3, this whole bracket will be my common factor. And I'm left with 2 and negative y. Part D, where we would have 3pq minus 3p plus 9 minus 9q. And I do see something. For this particular example, I saw that the q. And now, let's proceed on this question. The very first thing I saw that is common among all the terms. Yes, there is a common factor among all the terms. And that is the number 3. So that is the very first step that I'm going to take. And after I take out 3 as the common factor, I'm left with pq minus p plus 3 minus 3q. So there is this 3 that is always outside. And now, with the remaining 4 terms inside, then I'm going to break them out into 2 groups for me to continue to factorize. And I saw that I'm going to do something interesting. I'm going to rearrange and write as negative 3q, positive 3. Because I saw that the term with the q comes first for the blue color group. Now, this will make things slightly easier for us because then I saw that p is the common factor. And there is this. I'm left with q minus 1. Yes, because p times negative 1 will give me back my negative p. For the next green color group, I'm going to take out negative 3 and I'm left with q. You would see Mr. Tan writing negative 1 because negative 3 multiplied by negative 1 will give me back my positive 3. And once we have that, we still have the 3 outside. Then I saw that q minus 1 is the common factor. And I'm left with p minus 3. And this is the answer for part D. Let's move on to part E. Part E is straightforward. So we would have 2p as the common factor, and I'm left with m plus 8 divided by 2 would be 4. I'm going to take out negative n as the common factor, and I'm left with m plus 4. In case you are wondering why Mr. Tan write a plus, well, it is because with negative n as the common factor, when I take it out, if I were to expand them, this will give me back my negative 4n. Okay? And so, we can see that m plus 4 is the common factor. I'm left with 2p minus n. Let's move on to part F. Alright, this is straightforward as well with a catch. Okay? Because I saw that a is the common factor, I'm left with x plus y. Then I look at negative x and negative y. On the first look, that does not seem to have a common factor. But this is negative 1x and this is negative 1y. So what happens if I take out negative 1 as the common factor? I will left with x and positive y. Oh, because negative 1, if I were to multiply positive y, that will give me back my negative 1y. And from here, I could continue to factorize easily now with x plus y as the common factor. And I'm left with a minus 1. Yeah? That's a second version of doing things, which I'm going to share with you now. If I were to rearrange the term with ax minus x, positive ay minus y, then I can see that my x will be the common factor, and I'm left with a minus 1. My y is the common factor. I will left with a minus 1 as well. And you will also see that it does give me back my same answer. This is the equivalent version of the top. Okay? So the only catch is this particular method 2. I do something. I rearrange the terms. Okay? That is one thing that you can do if you are kind of stuck. Okay? And part G of this particular example. For this question, I am going to continue the approach. Okay? So for the first part, I saw that the highest common factor, notice 24 and 32, I could divide by 2, meaning I could extract out the 2, but that is not the highest common factor. What we are really interested in is extracting out the highest common factor. So in this case, it's 8. And I'm left with 3r and 4s. I'm going to extract out the q, negative q, and I realize that again I will have my 3r and positive 4s, because again Mr. Tan is really careful. If I were to multiply this out, they should give me back my negative 4qs. And from here, we can then see that 3r plus 4s is the common factor. I'm left with 8 minus q. Okay, so the key thing is we must extract out the highest common factor. Moving on to part H. Let's see. Looking at things as it is, okay, I can see that if I do break them into these two groups, the common factor here will be 4m, and when I do that, I will get 2n minus 1. Why is there 1 there? You might wonder, because if I were to expand and simplify this, I must get back my negative 4m back. As for the other green color group, well, there's no common factor, so to speak, but how about this? If I take out negative 1 as the common factor, what will happen? I will have my 2n minus 1, because again, if I were to expand out, I should get back my positive 1. Negative 1 times negative 1 is positive 1. And from here, I could then get that 2n minus 1 is my common factor, and I'm left with 4m minus 1. Next question. Okay. For here, let's have a look. It might be interesting to expand and simplify this, but wait a minute. If we observe the green color group, we can see that if I take out negative 2p out, I could actually get a plus 3b. Negative 2 as the common factor. Also have the p as the common factor. I'm left with a plus 3b. Again, you might wonder why is there a plus, because if I were to expand and simplify this out, negative 2p times positive 3p will give me back my negative 6p. Yep. And so from here, we can then saw that the a plus 3b is the common factor, and I'm left with 3 minus 2p. Part J. It's an interesting question. Okay, so before I do anything, I saw that for this, there is actually a common factor 3, yeah? So I'm going to just copy the question as it is first, before I do anything. And I'm going to extract out 3 as the common factor, and I'm left with x minus 3y. And then from here, I can just simply take out all the common factor now. If I compare 2 and 4, I know that there is a common factor 2. Also, x minus 3y is also a common bracket, meaning common factor. That's what I'm going to extract out as well. And I'm left with p here. Minus 4 is not 4 because I've extracted out 2, meaning I will have a 2 here, I still have 3 down there. And so final answer, it will be 2 times x minus 3y times p minus 2 times 3 is 6. So this particular question, I know that probably the first impulse is to expand and simplify first, but no. If we could factorize by taking out common factor, that may just prove to be a more elegant way of solving problems. Part K. Alright. So by now, once we have reached this particular part, you would be able to see that if I see the green group do not have any common factor, we could actually write as 1 times that whole group. Because I do see x power 2 as the common factor, and I'm left with x plus 1, and therefore here I'm going to write it as 1 times x plus 1, so that when I multiply this out, 1 times x, I will get back my positive 1x. 1 times 1, I will get back my positive 1. And the reason for doing so is because that will then allow me to see very clearly x plus 1 is a common factor. And I'm left with x squared plus 1. And for the last example of this particular video, for this particular question, the very first thing that caught my eye is that I saw a as the common factor across all the terms. I'm going to take out a as the common factor across all. I'm left with 2bc minus 3b plus 2c minus 3. Next, we'll kickstart my factorization by grouping. So this is the first group, and this is the second group. And from here, I saw that b is the common factor. Left with 2c minus 3. And I also saw that the other group has no common factor. But applying what we have tried thus far, I'm going to rewrite it as plus 1 times 2c minus 3. And we can do that, right? Because 1 times 2c will give me back my positive 2c. 1 times negative 3 will give me back my negative 3. And the reason for doing that is because then I can see 2c minus 3 as a common factor. And I'm left with b plus 1. And with that, we have come to the end of this particular example that has many questions about factorization by grouping. Yeah. So if you like this video at this point in time, do give it a thumbs up and subscribe. And let's move on to more questions on this topic. Hello everyone, welcome to this part of the video where we are going to explore 6 examples on factorization by grouping. Okay, so I'm going to zoom in on each example now. So for the first example, again, this is Mr. Tan's style. I do like to group them into 2 groups. That's why factorization by grouping. Then from here, I try to sieve out the common factor. So let's see. So this one, I do see that the common factor is letter or the variable x. Yes, x is the common factor. And I'm left with a minus, wait a minute, x, I've taken out x out, I'm left with, yes, 1. Why is that so? So that when I multiply back the x, I must get back my negative 1x. Okay? And at the other side, I realize there is no common factor between the variables a and 1. So what do we do in this case? A, 1, A, 1. I'm going to take out negative 1 as the common factor. And when I do that, I'm left with a minus 1. Yes. Okay, in case you are wondering why is that so, because when I expand and simplify, negative 1 times positive a, I do get back my negative a. Negative 1 times negative 1 will give me back my positive 1. And of course, last but not least, this is where we can then see that there is a common factor, a minus 1, this bracket. And that is what I will take out as a common factor. And I'm left with x and negative 1. Okay? So let's move on to the next example, B. Again, Mr. Tan going to break them out into 2 groups. And after which, I'm going to be equals to, in this case, x. And when I take out the letter, the variable x, I'm left with x minus y. On the other side, I see a positive 7 as the common factor. And I'm left with y minus x in this case. Now, how do I do this then? X minus y and y minus x are 2 different brackets, variable or expression. But, I could do something such that they are the same. So I'm going to just write this down first. Instead of writing positive y minus x, this is the same as, the equivalent form of this would be negative, still got the 7, okay, x minus y. So I have to repeat, positive y minus x and negative x minus y. They are what we call equivalent terms. Alright? Because if I were to expand and simplify, negative times positive x, I do get back my negative x. Negative times negative, I do get back my positive y. So now we have done this. We would then be able to see that, hey, x minus y will then be my common factor. And I'm left with x minus 7. Okay? So for this set of examples, most of them would require us to express equivalent forms, okay, as seen in this example. So let's move on to another example. And in this case, I see a 2p minus q. I also see a minus and q minus 2p. So this example is pretty easy to do because I do see 2p minus q. If I were to put as a bracket, there's actually a 1 in front. 1 times 2p is 2p, 1 times negative q is negative q. Why does Mr. Tan do this? Because Mr. Tan is going to put a positive, still got the m down there, but I will have a 2p minus q. Because Mr. Tan knows that positive 2p minus q and negative q minus 2p, they are equivalent terms or equivalent expressions. Okay? And once I have that, it becomes pretty straightforward already. We are going to apply what we have learned previously in this video. 2p minus q is the common factor. I'm going to take them out. And I'm left with 1 plus m. Of course, m plus 1 is also the same lah. They are equivalent terms as well. And we are going to have more practice on these equivalent terms. For part D, the very first thing I see across all 3 terms is that there is a common factor. Yeah? What's the common factor? 3. Yes. And therefore, I'm left with PQ minus P plus 3 minus 3Q. And then, at this point onwards, I'm going to factorize by grouping. So I would have my P as the common factor, left with Q minus, yes, brilliant, 1, very good, plus 3 bracket, yes, there is a factor of 1, 3 times 1 is 3, okay, minus Q. So this part here will be my 3, and after which, it is important at this point to see what Mr. Tan will do again. Mr. Tan saw the opportunity to rewrite this second line in an equivalent form. Negative 3 times Q minus 1. Again, for this part of the video, this is the 3rd time or even the 4th time you are seeing this. The positive 1 minus Q and negative Q minus 1. What are they called? Yes, they are called equivalent terms, which I'm going to just write it down here as well. And finally, I would then be able to factorize by taking out this Q minus 1 as the common factor. And I'm left with P minus 3. And let's move on to the next example here. And by now you should be pretty good at seeing things already, right? That the approach is always the same. I group them, and very importantly, the groups must have common factors. So in this case here, 5x. I'm left with x plus 3y 5 times 3 is 15. X times y is xy. I'm going to take out negative 2z. And I'm left with x plus 3y. And this particular example is pretty awesome in the sense that we don't need to do or rewrite or apply the equivalent terms technique. So we can actually see that for this x plus 3y is the common factor. Take them out. And I'm left with 5x minus 2z. And the last example for this part of the video, a minus b. Oh, there is no common factor. Hey, but wait a minute. But the green color group, there is a common factor c. And when I take them out as the common factor, minus c, I take negative c as the common factor, I'm left with a minus b. Oh, this is important. Why is there a minus? Because negative c multiplied by negative b must give me back my positive bc. And it is at this point where I'm going to do this. I'm going to put this as a bracket and write down 1. 1 times a is 1a, 1 times negative b is 1b. But why does Mr. Tan do that? To allow Mr. Tan to see very visually, very clearly that a minus b could be or is the common factor. And I will have 1 minus c. And with that, we have come to the end of this part of the video. And let's continue to explore more examples on mathematics. Thank you for watching at this point in time, and if you do want to, do subscribe to my channel. Hello everyone, welcome to this part of the video where we want to share with you. Mr. Tan here would like to share with you that when we approach questions for factorization by grouping, right, we could do it in a different method. Because students may rearrange the terms. What do I mean by that? Okay, so you see, for example, for part A, let's see what happened if we were to rearrange the terms. Like, for example, ax minus a, and then minus x is behind, positive 1 is... The positive 1 is behind, minus x is behind. Let's see what happens. Yeah? Will we get back the same answer as you would have seen previously in this video? I still have my blue color group and green color group. And this time round though, the common factor is a. I have my x minus 1. And at this stage, I saw that there is a plus 1 bracket 1 minus x. So of course, we have learned previously also already that when I see a x minus 1 and 1 minus x, what can we do? Yes, we can write its equivalent form, which will be x minus 1 negative. X minus 1 and positive 1 minus x, they are equivalent forms. And from here then, x minus 1 will then be the common factor. And I'm left with a minus 1, which is the same answer previously. Okay, so for part B, we could also do the same thing, and let's see what happens when we do that, okay? And so in this case, I could rewrite it as x squared minus xy minus 7x plus 7y. Okay, well, there's a reason for this, because I see the first group that I see, the term with the y variable is the second term. So I did this on purpose and see what happens. Okay, so in this case here, I would still have my x as my common factor, x minus y, but on the other end, I will have negative 7 now. Previously it's positive 7 in the other example. And when I do that, x, you will see Mr. Tan writing the minus y. And why does Mr. Tan write that? Because negative 7 times negative y must give me back my positive 7y. And when I do that, now I could see easily x minus y is my common factor. And I'm left with x minus 7. So in this particular approach, right, rather than applying the technique to write in equivalent forms, I actually rearrange the terms at the start. So this is the second method that I wish to introduce you all to. So let's continue to practice this. So for this particular example, again, I could then just share with you that I could, from the start, I could first expand and simplify. And after which, I saw that if I were to rearrange this to, for example, so this will be my 2p plus 2mp, because there is a common factor 2p. Then, because my m is at the second part, I will have my minus q and minus mq down there. Then from here, I could then apply the factorization by grouping already. 2p will be my common factor. Do remember, there's always the 1. 2p times 1 will give me back my 2p plus m. I will have my negative q taken out as a common factor. 1 plus m. Oh, why does Mr. Tan write plus a positive m? Because if I were to expand out and simplify, I will get back my negative mq. And from here, 1 plus m is the common factor. And I'm left with 2p minus q. So when you rearrange the terms, do try to keep it such that if you see that m is the second term of one group, I would also try to make sure that happens for the other group. Then it will make things easier. Okay? So let's continue to share with you this last example here that you have seen before. The first step is still the same. I'm going to take out 3 as the common factor. And from here, I have my pq minus 3 minus p, plus 3 minus 3q. And again, from here, I'm going to do some rearrangement, because I see if I were to stick to this current group, my Q is the first term, PQ minus P, right? I am going to shift the negative 3Q in front and rearrange the positive 3 behind. Well, there's a reason for that, because when I split them into the two groups and factorize, I will have my Q minus 1 here, negative 3. I would also have my Q minus 1. Again, for those who might be wondering why is my negative 1 instead of positive, because if I were to multiply negative 3 with negative 1, it will give me back my positive 3. And things now fell in place. Q minus 1 is the common factor. And I'm left with P minus 3. Alright, so the whole key message that I wish to share with you all for this part of the video is that there are different ways of solving, and for this particular way of solving, which I'm going to write at the side, we are actually, this approach here that I'm sharing with you is that we can rearrange the terms. Okay, we can do that. All right, and with that, we have come to the end of this part of the video. And thank you for watching thus far. And if you do like the video, do give it a thumbs up and subscribe to my channel. Hello everyone, welcome to this part of the video where we are going to first factorize by grouping an algebraic expression, right? Then, tapping on that factorization, evaluate a numeral expression. Okay? So let's see how does this work. So for part A, when we want to factorize this particular expression here, step 1, of course, I see 4 terms. I'm going to factorize by grouping. So I will see that the common factor is x. I'm left with y plus a. Common factor is a, and I'm left with y plus a. And so I will then be able to factorize out the y plus a. And I'm left with x plus a as the other bracket. Now part B, they require us to do this. They require us to use the above expansion or factorization. So right, my first step is to see and observe. Okay, and I do see similarities. Okay, I do see that if I were to break this up into 2 groups, I saw that for part B, I could rewrite 89 times 83 plus 89 times 17, right? As taking out the 89 out, and I'm left with 83 plus 17. I could take the 17 out as a common factor, and I'm left with 83 plus 17 as well. So you can then see that this 83 plus 17 will be as such. And I'm left with 89 plus 17, which is in the same vine as part A, factorization, right? And for your info, 83 plus 17 is a very easy number to add. It corresponds to 100 times, and 89 plus 17 will be 106. So final answer, 10,600. Alright, with that we've come to the end of this example, and let's move on to more examples that require us to factorize by grouping. Hello everyone, welcome to this part of the problem where we have a word problem now. Rectangle ABCD, the big one, is broken out into 4 smaller rectangles, okay, by the lines PQRS, and the respective areas are shown in the diagram itself. Write down and simplify an expression for the area of the blue color rectangle. Oh well, that is pretty straightforward. So for part A, the area of the rectangle ABCD is equal to, we just need to add them up. Yep. 21 AX plus 6AY plus 7BX plus 2BY. Done. Part B, find the length of AP, PB, ARDR in terms of AB, X, and Y. Well, the key idea now is, if I somehow know, okay, what is my length AD, and what is my length for AB, then that might give us some clue, okay? And we always remember that to find area of a rectangle or a square is length times breadth, right? So AD times AB equals to the area. Aha! This further give us some clue what should we do to the area that we have found in part A. So if we are able to factorize the expression found in part A, then we will be able to somehow find the length and breadth of this area. So this is what Mr. Tan is going to do. I am going to apply my knowledge of factorization by grouping, and to factorize them out now. 21AX plus 6AY, common factor is 3A, to left with 7X, 2Y. B will be the common factor, and I'm left with 7X and 2Y. And from here, I could then further factorize out the 7X plus 2Y. To lead me to this expression here. And when I compare this over, so I'm going to now go back to the question. I'm going to put side by side. So I'm going to just cut this out. And I'm going to put here side by side so that it's easier for us to see. Then I could see something already. I hope you can see. 7x plus 2y. I could put it directly into the diagram. 7x, 2y, 3a, and b, which is exactly what the factorized form of the area is. Can you see that? And once you can see that, then you can therefore write out what the question needs. So my AP will be equals to 3A. PB is B. AR is 7x. And DR is 2y. And with that, we have come to the end of this video. So if you like this video at any point in time, do give it a thumbs up, and thank you so much for watching this video and to learn about mathematics. Thank you and have a nice day.